So let's just move on further towards the associative property on the integers. First of all, we'll talk about the integers, which are nothing but represented as capital Z, which involves the elements as -2, -1, 0, 1, 2, and so goes on. So first of all, we'll talk about the associative property for the integers under addition. Means we have to show that for any three numbers, a plus b plus c should be is equal to a plus b plus c. If this particular condition holds, it means that the three numbers or the three integers are associative under addition. So let us suppose I am taking any three integers as -1 and -2 and -3. So I'm adding all these three numbers as -1 plus -2 plus -3. Okay, so on the second way, I'll take it as -1 plus -2 together and -3 outside of it. Okay, so the answer of the first one will be -1 will remain the same, plus we'll solve the bracket as -2 as it is, plus minus is -3. So the answer will be -2 -3. Okay, for the second case, the answer will be, we'll solve the bracket as -1 as it is, plus minus is minus. So minus of 2 within the bracket, plus minus is minus. So the answer is minus of 3. So let's just solve the first one as -1 plus of, we'll solve the bracket as -2 -3 is nothing but minus of 5, and the second one is nothing but -1 -2 is nothing but -3 minus of 3. So the answer of the first one will be -1 plus minus minus, so -1 -5, it is nothing but minus of 6, and for the second case the answer is -3 -3, which is nothing but again minus of 6. So it means that a plus b plus c, for this case the answer is always is equal to a plus b plus c, because both of them are giving the answer as minus of 6. It means that addition is associative in nature. So the result of this is nothing but addition is associative for any three integers, like this particular example where I have taken the three integers as -1 -2 -3. You can take any integers of your choice. Let's just move on further towards subtraction. Let us suppose I'm taking any three integers again, but we have to show that a minus b minus c must be is equal to a minus b minus c. If this particular condition holds, it means that the three integers are associative. If the condition does not hold, then the subtraction is not associative in nature. So let us suppose I'm taking three integers as 1 minus of 2 minus of 3. So let us suppose I'm taking 1, 2 and 3. So I am subtracting them as 1 minus 2 minus 3. And again, if I'll take it as 1 minus 2 minus 3, the answer will be 1 minus 2 minus 3 means 1 minus of 2 minus 3 is nothing but -1. And for the second case, 1 minus 2, it is nothing but -1 minus of 3. So for the first, it is 1 minus minus is +1. So the answer is 2. And for the second case, the answer is nothing but -4. So at the end, what will be the conclusion? That both of them are not equal to each other, because the answer of the first one is 2 and the answer of the second one is -4. It means that a minus b minus c is not is equal to a minus b minus c for a, b, c, any three integers. Hence, subtraction is not associative in nature. Subtraction is not associative in nature. So let's just move on further towards multiplication. Now we'll talk about the multiplication. Let us suppose we'll take any three integers. So we have to show that a into b into c is nothing but is equal to a into b into c. So let us suppose I'm taking an example, or I'm taking any three integers again. Let if we are taking 1, 2 and 3. If I'll multiply 1 into 2 into 3 in this particular manner, So let us suppose I'm multiplying over here. I'm taking A as 1, B as 2 and C as 3. So 1 into 2 into 3 will be same as 1 into 2 into 3. Why so? Because the answer of the first one is 1 into 2, it is 2 into 3, which is nothing but 6. And the answer of this one is nothing but 1 into 3 2 is 6. So 1 into 6 is nothing but 6, which means that A into B into C is equal to A into B into C. So this particular condition holds, which means that multiplication is associative in nature because of this particular example which I have taken over here, in which the A is 1, B is 2 and C is 3. So at the end, what is the conclusion? That multiplication is associative in nature. So let's just move on further towards division. Let if we are taking again any three particular numbers out of the collection of these integers. So let us suppose I am taking 1, 2 and minus 1. Let us suppose I am taking 1, 2 and minus 1. We have to prove that A divided by B divide C should be equal to A divide B divided C. Okay, we have to show that this condition holds for the division to be associative in nature, and I am taking 1, 2 and 3. Let us suppose I'm taking 1, 2 and 3. So we have to show that 1 divided by 2 divided 3 or 1 divide 2 divide 3, they both of them are giving the same result. So let us suppose I'm taking the first one. The answer will be 1 divided by 2 means that 1 by 2 division with 3. So this will be 1 by 2 in the numerator and 3 in the denominator. So the answer of this one is nothing but 1 by 6. So I am writing out the answer over here as 1 by 2 by 3 means 2 will be in the denominator with the 3. So 3 into 2 is nothing but 6. So the answer of this one is nothing but 1 by 6. But for the second case, the answer will be 1 divide 2 divided by 3 means 2 by 3. So it will be like 1 in the numerator and 2 by 3 in the denominator. So 3 will be in the numerator after solving it. So the answer is nothing but 3 by 2. So okay, so the answer of the second one is nothing but 3 by 2. Are they both equal to each other? Obviously they are not equal to each other. It means that A divide B divide C or A division with B divide C, they both are not equal to each other. If this property does not hold, it means that division is not associative in nature. That is, for any three integers A, B, C, this condition does not hold, and if this condition does not hold, it means that division is not associative in nature. So I hope this all clears to you that the associative property only holds if all these four conditions will hold for any three integers, if we are talking about integers. So let's just move on further towards the rational numbers.